Hello everyone, my name is Sahil Agarwal, Assistant Professor, Department of Information Technology. And today we are going to discuss an important topic of computer networks, which is data rate limits. So let's start with how can we increase the data rate limits? Means how can we increase the capacity of a system? So there are three ways. Let me write it here. First of all, first is we can increase the signal strength. Second, we can increase the bandwidth. And third, we can increase the quality. We will discuss it one by one. First of all, there is one part. We can increase the signal power. So first of all, we'll talk about signal. So if we increase the signal level, we can definitely get the higher capacity of a system. But there is one condition. Suppose there is one signal like this, and there is another signal like this. So if we increase the signal of this particular user 1, so it may touch this user 2, and it means there is a chance of crosstalk. So instead of getting the quality capacity of a system, we get the crosstalk. Although there is a situation when it works very well, when we don't consider any kind of breach in the system, or there is no need, or the data is not confidential, we can always increase the signal value. So a symbol, if we talk about a signal value consists by n, so the total signal will be 2 to the power n. Or we can say that a symbol can consist of a single bit or n bit, and the number of signal level is 2 to the power n. So if we increase the value of signal, instead of getting the increased value, we find the decreasing one. Next is we can always increase the bandwidth. But suppose there is a user 1, there is a medium between them, and there is a user 2. We can increase the bandwidth of this user 1. We can increase the bandwidth of this user 2. This is for sending, this is for receiving, but this is a transmission medium. And transmission medium has certain capacity beyond which it cannot go. So if it is demanding, suppose 100 Mbps, but the transmission medium can only give 50 Mbps at max. So whatever speed you are sending above 50 Mbps, it won't consider. That is why there is a certain limit in this by which we can increase the bandwidth of a system. So last is to increase the quality. But to increase the quality, we must know how noisy our channel is, or what is the bit rate of the channel is right now. For this, there is a two theorems given. One is Nyquist theorem. Second is Shannon capacity. Nyquist is given for noiseless channel. This is for noisy channel. First of all, we will talk about Nyquist theorem, which is a noiseless channel. So it finds the upper bound of a bit rate of a transmission system by calculating a bit rate. So if we talk about bit rate, the value of bit rate is C equals to 2b log base 2 L, where C is the capacity, which is considered in BPS. BPS means bit per second. B means bandwidth, and L means level of a signal. So level of signal is very important. It can be either written by L, or as we have discussed before, it can be written by 2 to the power n. Both are same. So bandwidth should be in hertz, or we consider bandwidth in hertz only. That is the formula of Nyquist theorem. Let's see one example of it. So suppose consider a noiseless channel with a bandwidth of 3000 Hertz transmitting a signal with two signal levels. So levels of signal are 2. Bandwidth is given equals to 3000 Hertz. The maximum bit rate will be, so first of all we need to see that this is a noiseless channel. It means we have to apply Nyquist theorem. So formula is C equals to 2 into bandwidth log base 2 level of signal. So 2 into 3000 log base 2 into 2. So log base 2 log 2 base 2 is 1 and 2 into 3000 equals to 6000. And the unit of capacity is considered in VPS, which is bit per second. That is the answer. So there is one more example. Consider the same noiseless channel transmitting a signal of 4 signal level now. Now we are talking about level equals to 4. So for each level we send 2 bits. The maximum bit rate can be calculated as, we are talking about the same noiseless channel, means the bandwidth was 3000 Hertz. So capacity will be 2 into bandwidth, which is 3000, and signal levels are log base 2 and this is 4. If we solve it, we will get 12,000 bit per second. That is the answer. Now we will talk about noisy channel. And when there is a noise involved, we will always calculate SNR. Means signal to noise ratio. Or we can say that we find the ratio of average signal power upon average noise power. So the formula of noisy channel will be capacity equals to bandwidth. Now there is a formula change, log base 2 1 plus SNR, where B denotes the bandwidth in Hertz and C is capacity, as always, capacity in bit per second. So let's consider one example of this. Consider an extremely noisy channel. Now we are talking about noisy channel only, in which the value of signal to noise ratio is almost 0. So it has given SNR equals to 0. In other words, the noise is so strong the signal is faint. For this channel, the capacity C will be calculated as, so we are talking about noisy channel, and the noisy channel we consider Shannon capacity theorem, which is equals to C equals to B log base 2 1 plus SNR. Now we will put the values of it. So C equals to B log base 2 1 plus 0. So when there is a B log base 2 1, so log 1 equals to 0, the bandwidth will be 0. When there is a faint signal, the capacity will be 0 BPS. Means we won't be able to send any kind of data with this type of noisy channel. There is one more example where we can calculate the theoretical highest bit rate of a regular telephone line. A telephone line normally has a bandwidth of 3000 Hz. The signal to noise ratio is 3162. Now values are given. Bandwidth is 3000 Hz. It must be given. There must be Hertz here. And signal to noise ratio is SNR equals to 3162. Find the capacity. First of all, when there is a noise is given, it means it's a noisy channel. We put the formula of C equals to B log base 2 1 plus SNR. Now we will put the value. B is 3000, SNR is 3162. So 3000 log base 2 3163. If we solve it, we will get 34860 bit per second. That is the answer. Or we can always write 34.860 kbps. So that is all about data rate limits. Thank you everyone. These are the references that I have taken. Thank you.